The introduction of chi-square. The chi-square is a non-parametric statistical test used to examine whether there is a significant difference between observed frequency and expected frequency in categorical data. It helps researchers determine whether variables related or whether observed results occur by chance. The test works by comparing the actual data, observed frequency, with the values that would be expected if there were no relationship between the variables' expected frequency. A larger difference between observed and expected value results in a higher chi-square value, indicating a stronger possibility that a significant relationship exists. The chi-square test is important because it allows researchers to analyze categorical data and make evidence-based decisions. Advantage of chi-square: simple and easy to calculate, suitable for categorical data, helps identify relationships between variables, and does not require data to follow a normal distribution. Limitation of chi-square: cannot be used for numerical or continuous data directly, requires a sufficiently large sample size, and show whether a relationship exists but does not measure the strength of relationship. The formula of chi-square is chi-square equal to sum bracket observed frequency minus with the expected frequency square divide by expected frequency.
So my name is Nurul Farawiyah and I will present on goodness of fit. So goodness of fit are a statistical model used to determine how well observed sample data to fit an expected theoretical distribution. So for example, if you roll a 6 dice 60 times, you would expect each number to appear roughly 10 times. So this test helps you decide if your actual results are close enough to those expected 10 times to prove the dice is fair. So if the or to see if the results are too far off, that saying the dice might be loaded. So for the key concept of goodness of fit, first we have observed value, which represent the actual data frequency that we collect from the sample or experiment. Now we have expected values, the data frequency to see if the null hypothesis is true. Lastly, we have degree of freedom, which to calculate as k minus 1 to represent the number of independent value that can vary in the analysis. So for the formula that we use is E equal to N times P, which E represents the expected frequency, N is the total sample size, and P is expected proportion. So next we have the chi-square statistic, which calculate by the sum of observed frequency minus expected frequency power of 2 divided by expected frequency. And lastly, we calculate the degrees of freedom, which the k minus 1. Now we look at our case study for goodness of fit. So our scenario is a local car rental startup named Our Car operate a diverse fleet consisting of MPV, sedans, and hatchback. So according to the automotive market projection, the customer demands is expected to follow specific distribution: 20% MPV, 40% sedans, and 40% hatchback. So to verify whether this market projection are currently aligned with actual booking trend, the operation manager need to analyze a sample of 200 vehicle booking from the past month. So the program we have is based on the actual booking data that we have provided. We need to conduct a chi-square goodness of fit test at 5% significant level to determine whether the distribution of our car customer vehicle choice fits the expected market projection. So for number of booking, which is the observed frequency, we have MPV 50, sedan 17, and hatchback 80. So my friend will explain the solution for this question.
This slide presents a chi-square goodness of fit test conducted for Our Car, a local car rental startup. The company expects customer demand to follow the market distribution of 20% MPVs, 40% sedans, and 40% hatchbacks. To verify this assumption, A random sample of 200 vehicles bookings was collected. The observed bookings were 50 MPVs, 70 sedans, and 80 hatchback. Next, we calculate the expected frequency based on the projected distribution. For example, MPV 20% of 200 equals 40 bookings, sedans 40% of 200 equals 80 bookings, hatchback 40% of 200 equals 80 bookings. Using the chi-square formula, we compared the observed and expected values. The calculated chi-square statistic was 3.75. Since there are 3 vehicles category, the degree of freedom are 2. At a 5% significant level, the critical chi-square value is 5.991. Because our calculated value 3.75 is less than the critical value 5.991, we fail to reject the null hypothesis. This means there is no statistically significant difference between the observed booking data and the expected market distribution. In conclusion, the actual customer booking behavior aligns with the market projection, indicating that our car's demand forecasts are accurate and provide a good fit to the observed data. Thank you.
Next is test of independence. This is a statistical used to determine whether two categorical variables are associated or independent of each other. For example, a teacher wants to know if gender influence student preference learning method, either face-to-face or online method. After collecting data and performing the chi-square test, the supposed result is significant, which is p less than 0.05. This means gender and learning preference are related, so the lecturer rejects the null hypothesis. In conclusion, students prefer learning method depends on their gender rather than occurring by chance. Okay, next is the key concept for the test in independence. First, the one is observer's value. This is the actual frequency recorded for each combination of category in the contingency table. Next is expected value, the frequency that would be expected in each cell if the two categorical variables were independent. Next is degree of freedom, calculated as R minus 1 in a column, C minus 1 in a column, where R is the number of the row and the C is the number of column in the contingent table. Independence, the assumption that occurrence of one variable does not affect the occurrence of another variables. Association, a relationship between two categorical variables indicated when the observed frequencies differ significantly from the expected frequencies. The formula used in this test in independence, the first one is we find the E, which is row total times column total divided by grand total. Then we move to the next formula, which is find the x power of 2 equals to sum of O minus E in a column power of 2 divided by E. After getting the answer, we will find the degree of freedom, df equal to R minus 1 in a column, C minus 1 in a column. From that, we will get the answer.
Today, I would like to present about chi-square test of independence. A chi-square test of independence used to determine whenever a relationship between two categories variable. In this example, the lecturer wants to figure out whenever its gender affects student preferred learning methods. It's a survey conducted among 100 students, and the result will show that 30 male students are prefer online learning while 20 prefer to face-to-face. Among female students, there are 20 learning online and the 30% was face-to-face learning. Okay, the first step is to state the hypothesis and the null hypothesis is no relationship between the gender and preferred learning method. In other words, the active variable independent, and the alternative hypothesis H1 is there a relationship between gender and preferred learning method. Next, you calculate the expected frequency using the formula. Expected frequency equal row total multiplied by the column total divided by the grand total. For this example, the expected frequency for each cell is 25, and then we calculate the chi-square using the formula. The chi-square equal to sum for the observed value minus expected value square divided by the expected value. After the calculation, the chi-square value obtained is 4. Next, we determine the degree of freedom using the formula. Is degree of freedom equal to column number of the row minus 1 multiplied by the number of column minus 1. Thereas the degree of freedom are 2 minus 1 multiplied with 2 minus 1 equal 1. At a significant level of 0.05 with degree of freedom, the critical value is 3.841. Since a calculated chi-square value is 4 is greater than the critical value is 3.841, and we rejected the null hypothesis. In the conclusion, there is significant evidence suggesting the gender and preferred learning method are related. Based on these studies, the male students tend to prefer the online learning, while the female students tend to prefer face-to-face learning.
In conclusion, the chi-square test is an effective tool for analyzing categorical data, testing hypotheses, and determining whether observed patterns differ significantly from expected outcomes. Its ability to identify meaningful relationships and trends make it an important method for research and decision making. That's all from our group. Thank you.